All right, our transformation that we're going to talk about today is reflections. Should be the second one on our list. I'm going to go through this quick little note-taking sheet, and then I have some other notes for you. So you're going to want to have a couple of pages of preferably graph paper. Notebook paper will work, but graph paper is probably easier to use, and you'll see why in just a second. Okay. So reflections. If you think about reflecting in a mirror or when something reflects across the water, a reflection is like when you take a shape and you flip it. Okay, so I'm going to write flip across here. You generally don't use the word flip, but it is a good word that kind of helps you or helps describe what a reflection is. It's a transformation in which a figure is reflected in a line called the line of reflection. So line. Okay, so we have, let's see if we can see that a little bit clearer. All right, in a reflection, the pre-image and the image are congruent. And I'm going to just use the symbol here because we should know what that congruent symbol looks like by now. Save us a little time. The corresponding angles have the same measurement. And the corresponding sides have the same measurement. So we're not changing the pre-image at all. It's going to be the exact same. Now, these are the rules that you need to remember when you're reflecting across either the x or the y axis. When we reflect across the x-axis, we're changing its position horizontally or vertically. Well, what changes vertical movement? Our y-coordinate. So if you look at this, xy becomes x comma negative y. In other words, all we're doing here is we're changing the sign of whatever the original y was. If the original y was positive, it becomes negative. If it was negative, it becomes positive. Nothing changes with the x coordinates. Okay, so if I have 3, 2, that becomes 3, negative 2. If I have 5, negative 6, that becomes 5, positive 6. That's all that happens. Now, if we're reflecting across the y-axis, the opposite is true. We're moving it horizontally, and I'll show you that in just a minute on a coordinate plane. But if I move it horizontally, well, my x-coordinate is what controls horizontal movement, so I'm going to change the x-coordinate. If you notice, the y-coordinate doesn't change at all. So if I have 3, 2, that becomes negative 3, 2. If I have negative 6, 5, that becomes positive 6, 5. All you're doing is changing the value of the x to the opposite of whatever it is. Okay, so just remember, reflect across the x-axis, change the y. Reflect across the y-axis, change the x. So we're going to start out just reflecting across the axis. And then we're going to move on to some other ones. Okay, so down below here we have a little triangle and a little simple triangle that we're going to use to start out with. And the coordinates, we got to list the coordinates for each one of them, and then we're going to list the coordinates for reflecting it across the x and then across the y. So the first one, I'm going to go over 3 and up 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 3, 8. And my B is going to be over 3, and it looks like it's up 3, so 3, 3. And C is going to be over 1, 2, 3, 4, 5, 6, 7. So over 7, and it looks like up 3. Okay, so there's our coordinates that we're going to start out with. I think I'm going to switch pens because I don't think I can see that one very well. Okay, let's go back to my purple. All right, so if I reflect across the x-axis, this tells me that I changed the value of the y's. Okay, so I'm going to, 3, 8 is going to become 3, negative 8. So 3, negative 8. and 3, 3 becomes 3, negative 3, and 7, 3 becomes 7, negative 3. Easy as that. No math involved, you just have to memorize the rule and change the sign of the y's. All right, so let's look at reflecting across the y-axis. Well, remember the rule up here that we just learned. When we reflect across the y-axis, we change the x. Should be a little negative right there. Change the x. When we reflect across the x-axis, we change the y. Okay, so we're going to take these original points as 3, 8, and we're going to change the x value. So this is going to become negative 3, and the y stays the same as the original. Here, 3, 3 becomes negative 3, 3. And 7, 3 becomes negative 7, 3. Okay, so let's go ahead and plot those. The first one's plotted for us, so let's plot the second and the third one. So A prime, this is across the x-axis, so it should lie, if this is the x-axis, it should lie somewhere down here. It should be flipped over that line. So let's see if that happens. I'm going to go over 3, 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7, 8, right about there. And that would be my A prime. B prime is going to be at 3, negative 3, so 1, 2, 3, down 1, 2, 3. So there's my B prime. And C prime is going to be over 7, down 3. 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3. And there's C prime. All right, let's draw our triangle and see what it looks like. Connect our points. And there's our triangle. I'm going to color it in. And you can see that it does look like, in fact, I literally just flipped it over that x-axis, this line right here. We would call that our line of reflection. Now let's change the line of reflection and let's make the y-axis the line of reflection. So when we reflect over the y-axis, these points right here should be where we end up at. So let's try to plot those and see what we come up with. Okay, so it looks like my A prime prime, or my first one, is at negative 3, 8. So I'm going to go this way. 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8. There's A prime prime. And B is going to be at negative 3, 1, 2, 3, up 1, 2, 3. There's my B prime prime. And my C is going to be at 7, negative 7, 3. So 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3. C prime prime. Okay, so there's my points. Let's graph that, or let's, draw that triangle and see what it looks like. Hopefully that shows up. So in fact, it does look like if I took this coordinate plane and I folded it on this y-axis and put it together, it would look like this would line up exactly on top of each other. Okay, so there's a couple more blanks on this sheet that we need to fill out, although we're not going to work on them too much. The first one is a figure has line symmetry. Line symmetry, that's kind of an important term that we're not going to work with too much right now, but let's go ahead and talk about that. A figure has line symmetry if a line called a line of symmetry divides the figure into two parts that are reflections of each other in the line. All right, So the reason I said don't worry about that too much right now is because we're going to do a whole lesson just on line symmetry at a little bit later date. So just kind of keep that in the back of your mind for right now. Okay, so I said that you're probably going to need some graph paper, so I do have some notes for you that I want you guys to be able to jot down. Let me zoom out just a little bit. Okay, so let's talk about notation. So notation is kind of a shorthand way for writing reflections, and so you'll see this a lot on maybe a test or on a worksheet, and you have to be able to read it. And the way that this is read is this lowercase r, okay, stands for reflection. So this is reflect across the x-axis, and I want to reflect point xy. That could be any point, okay? And this is just kind of another way to write what we already talked about. So the way you read this is reflect point xy across the x-axis, and it becomes point P prime, or its new image, if I change the value of y and keep the x the same. That's exactly what we just said on the other page. It's just another way that you might see it. Okay, here's another one. If I want to reflect across the y-axis, you're going to see a lowercase r, a y-axis kind of in a subscript, really small. P stands for just point xy, which could be any point. And what that means is that it's going to become P prime negative xy. So the x value is going to change. And again, these are just another way to write the rules that are on the other page that we just looked at. So I want you to be familiar with those. Lowercase r means reflection. We're going to get to rotation next, and they use a capital R for that one. So you don't confuse reflection and rotation. So reflection is lowercase r, and rotation is a capital R. Okay, so you might see it that way. Now let's talk about some other types of lines of reflection. The only two that we did on this page right here was we did across the x-axis and across the y-axis. We let the x-axis be the line of reflection, and then we let the y-axis be the line of reflection. But it doesn't always have to be one of the lines or one of the axis. It could be any line. So here's some common ones that you'll see. Okay, if you see a notation like this, this says I want to reflect point xy across y equals x. Y equals x is a standard notation for a diagonal, okay? The diagonal that cuts right through the coordinate plane and the first and the third quadrant. So the way you're going to do that in the rule, and you'll definitely want to put a star by this because you need to memorize this one, is another new rule. All it says is that you're going to take your xy of your pre-image and you're going to swap them. Okay? So if this was 2, 5, this one would be 5, 2. If this one was negative 6, 3, this would be 3, negative 6. You're not changing the signs of anything, you're just swapping the two numbers. All right? So here's an example of how that's done, or what that looks like. Okay, so here's a coordinate plane, and I drew a triangle over here in quadrant number, or the second quadrant, and this green line here is going to be my line of reflection. Okay, it's not going to be the x-axis or the y-axis. It's actually going to reflect over the green line. That is a diagonal. If you can see, it cuts this first quadrant and this third quadrant in half. Okay, so that's what the positive diagonal looks like. So we're going to take the coordinates of each one of these and we're going to apply this rule to them. All right, so A is going to be at, it looks like negative 3, 1. B is at negative 1, 1. And C is at negative 1, 4. Okay, So if I apply my rule to it, all I do is swap the two numbers. So A prime is going to be at 1, -3. B prime is going to be at 1, -1. And C prime is going to be at 4, -1. All we did was swap them. So let's plot those and see what they actually look like. Okay, so let's start up here with A. I'm going to go over 1 and down 1, 2, 3. And that's going to be my A prime. B prime is going to be at 1, -1. So that's B prime. And C prime is going to be at 4, -1. So 1, 2, 3, 4, -1. Okay, so let's draw that triangle. Let me find my ruler. So yeah, let me write C prime. And I'll do it in red. Just makes it a little colorful. All right, here we go. Here's our new image. And it does look like, in fact, I could fold this paper along this green line and those would actually lie right on top of each other. Think of like a butterfly with the butterfly wings, and you have to, if you close them, they will actually line up right on top of each other. Well, these triangles will do the same thing. In fact, but you have to fold it on that line of reflection. So since the line of reflection is my green line or my diagonal, that's the line that you got to fold it on. Okay, so here's another one. What if you get something that looks like this one right down here? So this one is actually the only difference between this rule and this rule is the first rule said reflect over y equals x. This one's going to be reflect over y equals -x. So the rule when you're going to do that and y equals -x is, in fact, let me show you down here, is the opposite. It's the negative diagonal. Okay, so it looks exactly like the green one. It's just cutting straight through the second and the fourth quadrant. Okay, so what you're going to do, the rule, and you'll definitely want to put a star by this, highlight it, whatever you need to do. You're going to swap them and you're going to change the signs. So that's the difference, okay? Up here, we didn't have to change the signs, we just swapped them. Down here, we have to swap them and change the signs. So I drew an example in here. So let's go ahead and list our original, our pre-image coordinates. A is going to be at 2, 1. B is going to be at 1, 2, 3, 4, 5, 1. So 5, 1. And C is going to be at 1, 2, 1, 2, 3, 4. So 2, 4. Okay, so you can see that all of my coordinates are all positive, which makes sense. It lies in the first quadrant, and all ordered pair in the first quadrant are always positive. So we're going to take these numbers, all right, we're going to swap them, and we're going to change them all to negatives. So this is going to become -1, -2, -1, -5, and -4, -2. All I did was swap them and change the signs. Now, if they were negative to begin with, I would have made them positive, but they're not. They're all positive, so I'm going to make them negative. Okay, so let's go ahead and plot these and see what it looks like. Okay, so -1, -2. -1, -2. Right there. There's my A prime. All right, my B prime is going to be at -1, -5. So -1, 1, 2, 3, 4, 5. There's my B prime. And C, or C prime, is going to be at -4, -2. So 1, 2, 3, 4, 1, 2. There's my C prime. Draw my triangle. And if I color it a little bit, it should look like that. So can you picture taking this and folding it on that line of reflection and seeing how those match up like the butterfly wings? But yeah, I think it would exactly line up. So that's how you reflect over the diagonals, the negative diagonal and the positive diagonal. All right. So there's one other thing that I wanted to show you before I end this video, and that is what happens if you have a line of reflection that isn't a diagonal, that isn't on one of the axes. What if it's just any vertical line or any horizontal line? Okay, so let's say we want to reflect over x equals 2. Well, remember, x equals any number is a vertical line. So I would first go to x equals 2, and I would draw a dotted line like this. That is, in fact, x equals positive 2. Okay, so we're going to let that be our line of reflection. I put a triangle up here, and we're going to take that triangle and we're going to reflect it over. So there's no steadfast rule like the other ones to do this. Instead, what you really need to do is think about distance, okay? And more specifically, distance from each point to the line of reflection. All right, so if I look at A is 1, 2 on the positive. So it's 2 units on the positive side of it. And since I'm reflecting over it, A prime has got to be 1, 2 units on the negative side or the opposite side of it. So my A prime prime is going to be right here, or A prime, sorry. Okay, they've all got to be equal distance. If I look at my C, oh, I don't want to use that one. If I look at my C, let's see how far my C is from the line of reflection. 1, 2, 3, 4, 5. Okay, so it's 5 on the right side of it. So my C prime has got to be the exact same distance on the opposite side. So 1, 2, 3, 4, 5. So my C prime is going to be right there. And my B, so let's look at the B. And I'm running out of colors. Oh, let's use green. No, I don't want to use green. Yeah, let's use green. Okay, so if I look at my B prime, B is 1, 2, 3, 4 units on the right side of the line of reflection. So my B prime is going to be 4 units on the left side. So count them over. 1, 2, 3, 4. There's your B prime. Okay, so now let's connect our points. All right, if I connect my points, I'm going to connect A to B. Oh, that's not working. A to B, A to C, I don't have my ruler, and C to B. Okay, so you can see that those look like the exact same triangles. They just, this one was just flipped over the line onto the other side. Always count the distance. If it is a line that is not one of the axes, actually, even if it is one of the axes, you're going to look at distance as well. And that can really help you because you can eyeball this, which is great. You don't have to do a lot of math. You just have to be able to count spaces. All right, there's my ruler. So let's look at a horizontal line. So remember, a horizontal line is y equals something. So I read this as lowercase r means reflect across y equals -3. So I'm going to draw a horizontal line, which I already did, at y equals -3. Just count down 1, 2, 3, and draw your dotted line. That's going to be my line of reflection. And I drew a triangle. And if you notice, my triangle actually intersects the y-axis, but that's okay. That's perfectly fine. I'm going to reflect this across this y equals -3. Okay, so it should lie upside down on top of that line. So we're going to do the same thing here. We're going to count distances. So if I go from A, let's just start from A. A is 1, 2, 3, 4 below. So A prime has to be 1, 2, 3, 4 above. A prime. Okay. B is 1, 2 units below. So B prime has got to be 1, 2 units above. And C is 1, 2, 3 units below. So C prime has got to be 1, 2, 3 units above C prime. So let's watch how nifty that is. Okay, so let's connect our points. A to B, B to C, and A to C. So do they look like mirror images? Does it look like I just took this and literally flipped it across that y equals -3? It sure does. It looks like I could fold this paper on that dotted line and they would match up and lie right on top of each other. Okay, so anytime you have a line that you're reflecting across that is not the x or y axis, just remember, draw your line of reflection and then count the distance from each one of the vertices. It has to be equal distance. All right, I think that covers it for now. We might add more to this later, but I think that should get you through all of your practice problems. All right, have a great day, everybody. See you tomorrow.